Assalamualaikum and good day to all students basic mathematics TUM 1113. So we go to the last subtopic in chapter 1. Okay. So we look at 1.4 complex numbers. So complex number arise when the evolution of mathematics lead to the equation with no real solution, such as x squared equal to -1. Okay, so for this equation there is no real x that can be squared to produce -1. So in order for such equation to have solutions, mathematician introduce imaginary unit, which is I, okay, to replace square root of -1. Okay, so I equal to square root -1. So before this, we only know that if you want to square root, all the numbers inside the square root should be positive, right? So here in complex number, we have that particular negative number in square root, which is equal to I. We call it as an imaginary unit. So definition, complex numbers. So let a complex number denoted by a letter Z, then the standard form of complex number can be written as Z equal to X plus YI. So where X and Y are real numbers. Okay, X and Y are real numbers and I is the imaginary unit. So in this case, the real number X is called, so X is called the real part of Z. So written X equal to real number part of Z, and the real number Y is called the imaginary part of Z. So written Y equal to IM for imaginary, okay, part of Z. Okay, so we look at examples, some examples of complex number. Okay, so look at this. So complex number, for example, 1 plus 9i. Okay, so means that we have two parts here. The first one without I is a real part, so with I is a imaginary part. So real part equal to 1, imaginary part equal to 9. Okay, same to this one. Okay, look at 3 here, 3i. 3i, so we have I here, so means that 3 is in imaginary part, but we don't have real part, so we put 0 here. Okay, so if -2, so with the I, right, so no imaginary part, so imaginary part equal to 0, so the real part is -2. Okay, and so on. Okay class, so this is the pattern of imaginary unit. Okay, so we know that here, so we know that I equal to square root -1. Okay, so this is I. So how to find I square? Okay, so I square equal to square root -1 times square root of -1. So we will get -1. Okay, so this is I squared. So I power of 3. So I power of 3. So we know that I power of 3 equal to I squared times I. So I squared is -1 here. So I is I. So we will get -I. This one for I power of 3. And I power of 4, okay, equal to I squared times I squared. So I squared is -1. -1 times -1, we will get +1. So if you know this one, So it's easily for you to find I power of 5, I power of 6, and so on. Okay, so for example this one, I power of 12. So I power of 12 equal to I power of 4 times I power of 4 times I power of 4, right? So if you 4 plus 4 plus 4, you will get 12 here. Okay, so and we know I power of 4 is equal to 1. So 1 times 1 times 1, we will get 1. Okay, class? So you just remember this 4 only, then you can solve for any number. Okay, here. Okay, so let's look at example here. So write the following in standard form of complex number. Okay, so 5 minus square root negative 9. Okay, so here negative 9 is actually negative 1, square root of negative 1 times square root of 9. So 9 times negative 1, we'll get negative 9, right? So negative 1 is a I. Okay, and square root 9 is a 3. So this is the standard form of complex number. 5 minus 3i. Okay, so same to be. So square root 16 is a 4. Okay, square root 16 is a 4. Plus square root negative 4. So square root negative 4 is actually square root negative 1 times square root negative 4. And we know that square root negative 1 is a I. Square root 4 is a 2. So the answer is 4 plus 2i. Okay. Look at D. So 3i power of 36. Okay. So here, okay, we can do like this. So I power of 2 in bracket power of 18. Okay, so because 18 times 2, you will get 36, right? And we know that I power of 2 is negative 1. Okay, so negative 1 times 18, you will get 1. So 1 times 3, the answer is equal to 3. So here is operation on complex number. Okay, so we look at the first operation here, addition. Okay, so z1 plus z2. Okay, z is a complex number. So the first z is x1 plus y 1i plus x2 plus y 2i. So the concept here, you add the real part here, x1 plus x2, and then you add for the imaginary part, y1 plus y2. Okay, so look at this example. Okay, this one. Okay, so negative 3 plus 2i plus 5 minus 3i. So how to find the solution here? So first you add the real part. So negative 3 plus 5, you get 2. And then for imaginary part, 2 minus 3, you get negative 1. Don't forget to put I here. Okay, so seems to subtraction. Okay, so you minus the real part first and then the imaginary part. Okay, don't forget to put I. Okay, so for multiplication, okay, look at this. For multiplication, for example, z1 multiply z2. So here this one is same if you multiply two bracket. Okay, if you multiply two bracket and have operation in between the values, So you just do like that. So x1 times x2, x1 times y2i. Okay, so y1i times x2 plus y1i times y2i. Okay, so you'll get I square here. So we know that I squared is a negative 1. So that's why here we get negative. So x1, x2 negative, y1, y2 plus x1, x2 plus x2, xy, I. Okay, then we have conjugate. Okay, this one is very important in complex number. So what is a conjugate? Okay, so this is the symbol for conjugate, the small star here. Okay, so conjugate is, okay, for example, this is z1. So z1 is x1 plus 1 y1i. So if you want to find the z1 conjugate, so the plus here become negative. Okay, only on the imaginary part. Okay, you change the sign in the imaginary part only. Okay, so the real part is same. So this one positive, this one also positive. But for the imaginary part, if this one positive, this one should be negative. Or if this one negative, this one should be positive. Okay, and then you multiply it. Okay, look at this example. Okay, so this is z1. So conjugate z1 is 5 plus 7i. Okay, so just change the sign for the imaginary part only. Okay, so division. Okay, so division for complex number is a little bit different. Okay, so if you want to find z1 divided by z2, so x1 plus y1i divided by x2 plus y2i. So you need to multiply by this fraction. Okay, so if this positive, okay, this one should be negative. Okay, so actually you multiply by 1. Okay, this one is equal to 1, right? Okay, this one equal to 1. Okay, so but we change the sign here because we want to delete the I below here. Okay, so if we multiply it, we will get the real part only. We didn't get any imaginary part. Okay, for example, this one 3 plus 6i divided by 7 plus 2i. So we multiply by 7 minus 2i divided by 7 minus 2i. So after all, you will get the below one is a real part only. So we didn't have any imaginary part. Okay, so definition complex conjugate. So if z equal to x plus yi, then its complex conjugate is denoted by z star. Okay, so this is the symbol for complex conjugate and written mathematically as follows. Okay, so like I mentioned before, so if this is positive, this one should be negative, or if this one is negative, this one should be positive. Okay, so this is example. So given the following complex numbers z1, we have z1, z2, z3 and z4. Okay, so you need to find z2 plus 5z3, 2z2 minus z3, z2 times z3 divided by z3, and z2 times z2 conjugate. Okay, so here is the solution for E. Okay, so if z2 is 2 plus 8i, so the conjugate for z2 is 2 minus 8i. Okay, so don't forget class, this one you need to replace I squared must be equal to negative 1. Okay, so why you have only real part, no imaginary part? Because 16 minus 16 you'll get 0, so no imaginary part here. Okay, so this is the solution for A, B, C and D, but I want to show you in details for D how to find this solution, z2 divided by z3. Okay, so look at this one. So z2 equal to 2 plus 8i and z3 equal to 9 plus I. So if you want to find z2 divided by z3, so 2 plus 8i divided by 9 plus I. So remember that if you want to divide the complex number, so we need to multiply the conjugate. Okay, below here the conjugate above and below. Okay, so 9 minus I, so because it's 9 plus I, right? So we multiply by 9 minus I divided by 9 minus I. Okay, so this is actually equal to 1. So 2 plus 8i above here. Okay, so we multiply by 9 minus I, and below 9 plus I we multiply with the same values here, so multiply 9 minus I. Okay, then we get 18 minus 2i plus 72i minus 8i squared. Okay, so remember that class, so we replace this value with negative 1. So, okay, so same to this one. So if you see I square, you need to replace it with negative 1. Okay, and then this one we can cancel. Negative 9i plus 9i, we get 0. So we simplify it, and then we get this solution, 26 plus 70i divided by 82. Okay, so this is another example. So express the following in the form of x plus yi. Okay, so 3 minus 4i divided by 6. So you need to separate into two part here. Okay, real part and imaginary part. So just separate like this. So 3 divided by 6 minus 4i divided by 6, then we get this answer. Okay, so if B and C, look at B and C, because we have imaginary part in the denominator. Okay, so you need to multiply by the conjugate. Okay, so below and above, so both below and above. Okay, so you multiply with the same number here, so negative 2i. Negative 2i, so because of this one is 2i. Okay, so times with negative 2i here, so the above one, so 2 minus 3i times with negative 2i, then you'll get this answer. So don't forget, replace it I squared here. Okay, so replace with negative 1, so that's why you get negative 6 here, and you get 4 here. Okay, and then you separate it. Okay, so you'll get negative 3 over 2 minus I. Okay, you can try for C and D. Okay, so I give you the solution here. Okay, just try and make sure you do all the example. So this one I want to show you example D. Okay, so how to find the solution for D. Okay, so because of we have a square root here. Okay, we have a square root here, so 1 plus square root 2i squared. Okay, in bracket squared, so means that 1 plus square root 2i times 1 plus square root 2i. Okay, so you just multiply it, so each of the values here, so you get 1 plus square root 2i plus square root 2i plus, okay, this one square root 2i times square root 2i. Okay, so here we use the properties here. So if square root a times square root a, you'll get a. So make sure this one is the same number, both are same number, then you get that number without square root. Okay, so square root 2 times square root 2, you will get 2. So I squared here, so square root 2i plus square root 2i, 2 square root 2i, you will get this value. Okay, and then you replace I squared with -1, you simplify, then we will get the last answer is here, -1 plus 2 square root 2i. Okay, so this is the exercises for you to do, so make sure you do all the exercises, and then you can discuss with your lecturer during your online class later. Okay, class, so that's all for today. Thank you.